Good morning, young physicists. Have you ever wondered why a camel can walk easily on desert sand while your feet sink right in? Or why it's easier to cut vegetables with a sharp knife than a blunt one? The answer lies in two simple but powerful concepts: thrust and pressure. Let's begin with thrust. When a force acts perpendicular to a surface, we call that force a thrust. Imagine placing your hand on a wall and pushing. The force you apply straight into the wall is your thrust. Now, when that thrust is spread over a certain area, we get pressure, the effect of the force on the surface. The relationship is given by the formula P equals F divided by A, where P is pressure, F is the thrust or force in newtons, and A is the area in square meters. Pressure tells us how concentrated or spread out a force is. For the same force, a smaller contact area produces higher pressure. That's why knives have sharp edges. The smaller area increases pressure, making cutting easier. As you'll see in the diagram, when the same thrust acts on two surfaces of different sizes, the smaller one experiences more pressure. Now that we know what thrust is, let's look at its nature. Thrust is a vector quantity. It has both magnitude and direction. It always acts perpendicular to the surface on which the force is applied. For example, when a person stands on the floor, the body exerts a thrust equal to its weight, or mass multiplied by acceleration due to gravity, that is, thrust equals m times g. If you lean against a wall, you apply thrust sideways. But when you stand upright, the thrust is vertical, directed downwards on the floor. In the diagram, you'll notice the downward arrow representing thrust and an equal upward arrow showing the reaction from the floor. This balance allows you to stand still. In short, thrust measures how strongly a body presses on a surface. It's the perpendicular component of the force acting on that surface. Let's now focus on pressure, the real star of this concept. Pressure tells us how much force acts per unit area. It depends directly on the force applied and inversely on the area of contact. Think about walking on snow. When you wear normal shoes, your weight acts on a small area, so the pressure is large and you sink. But if you wear skis, the same force is spread over a bigger area, pressure reduces, and you glide smoothly over the surface. The same rule applies in engineering and daily life. Tank treads are wide to reduce pressure on soft soil, while nails have pointed tips to increase pressure and pierce wood easily. The relationship stays the same, P equals F divided by A. The smaller the area, the greater the pressure. The larger the area, the smaller the pressure. As the diagram shows, pressure distribution changes dramatically with area, even when the total force remains constant. Now let's apply these ideas in a simple calculation. Suppose we place a block of mass 10 kilograms on a table. The surface area in contact with the table is 0.05 square meters. First, we find the thrust, which equals weight. So, thrust equals m times g equals 10 times 9.8 equals 98 newtons. Next, using P equals F divided by A, we calculate pressure equals 98 divided by 0.05, which equals 1960 pascals. That means the block exerts a pressure of 1960 newtons per square meter on the table. Notice how even a small object can create a large pressure when the area of contact is small. This is why sharp heels can leave dents on wooden floors while flat shoes don't. In the diagram, you'll see the block pressing on the table with arrows showing the force and the resulting pressure area. Let's sum up everything we've learned about thrust and pressure. Thrust is the perpendicular force acting on a surface, while pressure is the effect of that thrust per unit area. Their relationship is given by P equals F divided by A. Pressure increases with more force or a smaller area. the unit of thrust is the Newton and the unit of pressure is the Pascal, which equals 1 Newton per square meter. In everyday life, these two concepts explain a lot, from why knives are sharp to how aircraft wings create lift to why snowshoes keep you from sinking. So, next time you're walking on soft ground or pushing open a door, remember, every action involves thrust and pressure quietly working together.